Hello friends, welcome. In this video, we will study the rules used in block diagram reduction technique. The rules are: first is associative law, second is blocks in series, third is blocks in parallel, fourth is shifting summing point behind the block, fifth is shifting summing point after the block, sixth is shift the takeoff point behind the block, then seventh is shift the takeoff point after the block, eighth is removing minor feedback loop. Let's start. First is the associative law. Associative law. Associative law is related to summing point. Related to summing point. Let's take these two summing points. This is R1, this is R2 and this is R3. This is minus and this is plus. Then here this summing point gives us R1 minus R2 and this summing point gives us R1 minus R2 plus R3. And here now this is one summing point, this is second, this is arrow. If we move this summing point behind and this summing point to the right hand side, then see what will happen. R1, this is R3 here, this is R2, this is plus and this is minus. Here now this summing point gives us R1 plus R3 and this summing point gives us R1 plus R3 minus R2. See here, in associative law the final output is same. That is here R1, this is here plus R1, here plus R1, here minus R2, here minus R2, this is here plus R3, here plus R3. This is called as associative law. Second is blocks in series. Blocks in series. This law is related to the blocks arranged in series. Related to blocks arranged in series. Take these three blocks arranged in series. This is G1, G2 and G3. This is RS and this is CS. This gives us CS upon RS is equal to G1 into G2 into G3. This law says that is blocks in series law says that if blocks are arranged in series, then each block we have to multiply like this. This is blocks in series rule. Third is blocks in parallel. Third, blocks in parallel. In this law, the blocks are arranged in parallel position. Blocks arranged parallel. Let's take this is one block, this is second, and this is third. This is G1, G2 and G3. This is summing point, and this is RS, this is CS. Let's take this is plus, this is minus, and this is plus. Here these blocks are arranged in parallel position. Here CS upon RS is equal to G1 minus G2 plus G3. In blocks in parallel rule, we add or subtract the blocks arranged in parallel like this. Here the sign of the G1 is plus, sign of the G2 is minus, and sign of the G3 is plus. This is called as blocks in parallel rule. Now, fourth is shifting summing point behind the block. Shifting summing point behind the block. In this, we shift the summing point behind the block. Let's see. This is G block, this is summing point, this is R, this is Y, this is plus, and C, S. In this case, CS is equal to RG plus Y. If we shift this summing point behind the block, that is here, then also the output will be the same. Let's see how it is. This is block, this is our summing point, this is R, this is plus, this is another block which has value 1 upon G, and this is Y, this is G, and this is CS. Here in this case, when we shift the summing point behind the block, that is here, then we need to add one block which is equal to 1 upon G, this G, and because of we moving this summing point behind this block, so that we have added block called as 1 upon G here. So here CS is equal to R plus Y upon G into G. Here we get then C of S is equal to RG. This G and G gets cancelled, so plus Y. This is equal to this, same. Fifth is shifting summing point after the block. Shifting summing point after the block. In this case, we will shift the summing point after the block. Let's see. This is a summing point, this is a block G, this is R, this is plus Y, then and this is then R plus Y. This gives us R plus Y into G. In this case also, the final output of this and after shifting the summing point after the block will be the same. Let's see. Here this is R, this is G, then here this is our summing point. Here we need to add the same block, that is here G, like this, and this is Y, this is plus, then this gives us CS is equal to RG plus GY, that is this is equal to here R plus Y is into G. These both outputs are same. In shifting summing point after a block rule, only we need to shift this summing point after the block and need to add a block same as this, that is the block after which we have shifted our summing point, that is this one. This is called shifting summing point after the block rule. Sixth is shift the takeoff point behind the block. Sixth is shift the takeoff point behind the block. In this case, we will shift the takeoff point behind the block. See, this is G, this is R. Here the output of this will be R into G. If here will be the takeoff point like this, then here Y is equal to RG and this is C is equal to RG. The output of this R and G, that is RG, is divided into two arrows. Here it is C is equal to RG and here it is Y is equal to RG. This is takeoff point. If we shift this takeoff point behind the block, that is here, then see what will happen. Here this is G, this is C and this is our takeoff point. Here we need to add G, same as this. Here this is R, then this R goes here, so Y is equal to RG and this R also goes here, so C is equal to RG. See, the final output of both the conditions is the same, that is C is equal to RG here also and C is equal to RG here also and Y is equal to RG here also and Y is equal to RG here also. In shift the takeoff point behind the block, only we need to shift this takeoff point behind the block, that is here like this, and we need to add the block G same as the block behind which we have shifted the takeoff point, that is here G. This is called shift the takeoff point behind the block rule. Now seventh is shift takeoff point after the block. Seventh is shift the takeoff point after the block. In this case, we will shift the takeoff point after the block. See, this is G, this is our takeoff point, this is R, then Y is equal to R, this R goes here also, then here C is equal to RG. Here if we shift the takeoff point after the block, that is here, then see what will happen. Here this is our block G, this is R and this is C. if we move this takeoff point here after the block, we need to add a block 1 upon g, and this is y here. Then after this it will be, its output will be Rg. This Rg will go here and here also. So here then y is equal to R as Rg into 1 upon g. G gets cancelled, so R, and C is equal to Rg. Here C, in both the conditions the final output of C and C is same, and final output of Y and Y is same. In shift the takeoff point behind the block, in the shift the takeoff point after the block rule, only we need to shift this takeoff point after the block, that is here like this, and we need to add a extra block like this 1 upon g. This is called shift the takeoff point after the block rule. Last is, that is eighth, is removing minor feedback loop. Eighth, removing minor feedback loop. In this rule, we remove the feedback loops step by step. That is, the number of blocks we arranged in a single block. See, this is a summing point. This is G of S. This is C of S. This is R of S. And this is a feedback loop H of S block. This is plus or minus. Then we will make it in a single block like this, R of S. This is a single block, and this is a C of S, and its value will be G of S upon 1 plus minus G of S into H of S. This is a transfer function of this control system. Friends, I have explained how to derive this transfer function in my video. The title of the video is Derivation to Find Transfer Function of Simple Canonical Closed Loop System. The link of this video I have given in the description. Thus, in this video we have studied 8 rules used in block diagram reduction technique. Thank you friends for watching this video. Like and share this video and subscribe my channel. Thank you.